So that video with the jazzy music, hopefully you could see it on the lesson, was showing us in practical terms the relationship between a square-based pyramid and a square-based prism. And so if we have the same base, then the relationship between those two things is just that one of those is 3 times the volume of the other. The cube or the prism is holds 3 times as much as the the pyramid. And so if we look at that the other way, if we already have a formula or equation to find the volume of a square-based prism or box in more usual language, then all we have to do is take the volume of that and divide by 3, and that will give us the volume of the pyramid with the same size base. So if I draw that same square base, then if I have a pyramid coming off of that, then the volume of this prism, if I take it and divide it by 3, it gives me the volume of this pyramid. And so we don't need a new formula. We just need to find the equivalent prism or box and just divide the volume by 3. It's that easy. And remember that volume really doesn't even need its own formula either, because if we start with the if we start with the area of the base, let's look at a rectangular base prism. If we know the area of this two-dimensional shape, which is just length times width, we did that in our last lesson, then if we make this into 3 dimensions, the only thing we've done is add a height to our figure. And so now we have the height in there. So if we've already calculated the area of the rectangle on the bottom, the only thing we need to do to make this volume is multiply by the height. And so all of our area formulas will work for volume. We just need to multiply in that extra dimension, that third dimension that makes this a 3-dimensional shape, which is the height. So here's 2 rectangular based prisms or boxes, and we're going to use what we just talked about to find the volume of both of these shapes. Let me move this over just a little bit so we have everything visible. Okay, so if we start with this first one with A, and we're looking just at the rectangular base, the 2-dimensional shape on the bottom that it's built off of, then the area is just 9 times 7, which is 63 centimeters squared. If I want to make that into a volume now, then I have to add that third dimension, and I'm just going to take my area and multiply by the height, and so I have 63 centimeters squared, and I'm going to multiply that by 13 centimeters. Now remember, with our exponent laws, we can look at this centimeters as centimeters to the 1, and so when we're looking at units, we've got centimeters squared times centimeters to the 1. We're going to add those exponents just as if centimeters was a base of an exponent, and we're going to end up with 819 centimeters cubed. And that's all we have to do when we're being asked to find the volume of a box. So in our second diagram, we've got some fractions here, but these fractions are easy to work with, and decimals are just fine when we're doing area and volume. And so again, if I want to find the area of the base of this box, then I'm just going to take area equals 7.5 times 4, and those are both in inches. And so 7.5 times 4 is going to give me 30 inches squared, or sometimes in the old days we used to write that as square inches, SQ.IN. So you might see that measurement, especially if you're going to go into trades. Now that I want to make this a volume, I'm going to multiply in the third dimension of height, which makes this a 3-dimensional shape. So I'm going to start with my area of 30 square inches, and I'm going to multiply by the height, which is 2.5 inches. And remember, that's like inches to the 1, so volume is always a cubic measurement or a 3-dimensional measurement. And so here we're going to have 75 cubic inches for our volume. And if you are a car person, back in the old days, we also used to measure engine size according to cubic inches. And so if you had a 350 V8, it meant that your engine was had a volume or a capacity of 350 cubic inches. So here's where the math really gets fun, because we talked about the relationship of the pyramid to the prism or the box, and that relationship is a factor of 3. So if I take the volume of this and I multiply by 3, I get the volume of the box. And since the volume of the box is so much easier to find, why don't we start there and then just divide by 3 to get our pyramid? So I'm going to go over here. I'm going to find the volume of our box just by doing 4 times 4, that's the area of the base, and then multiplying by 9, which is the height of the box. And so that's 36 times 4, and that's 144 units cubed. They didn't give us units this time, at least not on the box, and so I'm going to put units cubed. All right, so we have 144 cubic units for the volume of our box. We know the relationship as long as the base is exactly the same area as the base of our box, that all we have to do, and you will notice that we have the same height, is go over here and say volume equals 144 divided by 3. And that's going to be equal to 48. And we do have units here. We know that it's centimeters cubed or cubic centimeters, and that's where the cc comes from when you're working in medicine. If you give someone like 10 cc's of epinephrine or something, that's what they're talking about, 10 cubic centimeters, which is equivalent to a milliliter. So in these last two examples, we're going to find the volume of the pyramids. And if you like that idea of starting with the square-based box or prism, sorry, I'm just drawing it out for you here, then we can start like that every time. And we know that the volume here would just be 10 times 10 times 18, and that would give us 1,800 centimeters cubed. And so if I go back over here to the pyramid, all I have to do now is say 1,800 divided by 3, and that's going to give me 600 centimeters cubed for the volume of the pyramid. If we do the same thing for the next question, we've got a base of 8 times 8, and they put some extra dimensions on here, maybe to confuse us a little bit. They put the slant height, which we can use when we're finding surface area, but not volume. We need the perpendicular height, or the altitude of this pyramid, and that's this value 6, and we know that that's true because of the 90-degree angle at the bottom. That's the number we're looking for the height. And so when we find the height, we could take 8 times 8 times 6, and then divide by 3, because this is a pyramid and not a prism. And so 8 times 8 times 6 is going to give us 128, and they didn't give us any units this time, so we're going to write units cubed. In your notes section for this lesson, this is lesson 3, volumes of prisms and pyramids. I think that if you write out the volume formula for a box or a rectangular prism, and just put beside it that pyramids, you just take the same number and divide by 3, then that's the easiest way to do these problems, and you're always going to remember that. And so add that to your notes page so that you remember it for the test.